Osmosis. This is another colligative property. Osmosis is the flow of a solvent from a less concentrated solution to a more concentrated solution. And so this happens when solutions containing a high concentration of solute draw solvent from solutions containing a lower concentration. The way I think of this is nature is always trying to make things even, right? Level. It doesn't like things to be at different levels. And so here you've got one solution that's concentrated and one solution that's less concentrated. It's a little bit like Robin Hood, you know, rob from the rich and give to the poor. And so he's trying to make them both the same concentration. That's what osmosis is trying to do. So how does this happen? Well, here's an example. If you're stuck on the ocean, if you're, stranded in a boat in the ocean, you're going to get thirsty. Don't drink the ocean water. Not only does it taste terrible, but it's going to make you more dehydrated than if you don't drink anything due to osmosis. So here's an illustration of your intestinal wall. So here's outside of your intestine where there is salt in the water because all of the fluids in your body have a certain amount of salts, dissolved ionic compounds. And here's inside your intestine, ocean water, if you're drinking that, is going to have a higher concentration of salt than is in the tissues in your body. And the membranes along your intestine are permeable to small ions and molecules. So the water can go through, the sodium and the chloride are not going to go through. And so what happens is water will be drawn out of your body into your intestines by osmosis. It goes from the low concentration to the high concentration as if it were trying to dilute the more concentrated solution. We can see this happening in a U-shaped tube. We used to call them U-tubes, but that's become something else now. A U-shaped tube, and we have a semi-permeable membrane. It allows some things to pass through, but not others. So it allows the water to go through, but it doesn't allow the solute particles, which are too big. So here we have pure water on one side and salty water on the other side. Water is going to go through in both directions, back and forth, but it's going to go preferentially to the side with the higher concentration. As water moves to this side, this concentration decreases because its volume is increasing. What we see happen is that the level of liquid on this side of the tube rises and the level on this side falls as water moves itself through the membrane over here. That doesn't look like that should happen, does it? It's like, wait, what? What's going on? I thought we said everything's trying to get level, right? Well, here the water is trying to lower this concentration by coming over here and diluting it, and in the process, it causes the level to rise up here. Now, this is going to cause a difference in pressure on this side and that side. Remember when we talked about the mercury barometer? We can measure the height of this column. Now, this isn't mercury, this is water, but we can measure this pressure. That's called the osmotic pressure. The osmotic pressure is the pressure you would have to apply to this side of the membrane to prevent the osmosis from happening. Otherwise, it's going to do this. And it's going to keep going until it reaches a certain osmotic pressure. It won't keep going indefinitely because gravity is pulling down on it, and so it is opposing the force of gravity. So osmotic pressure is the colligative property. It depends on the concentration of solute particles, not on what they are, just the number of them. So this is another one that uses molality. So semi-permeable membranes are, your body's full of them. Every living organism has them. They're really, really important. And your body uses osmosis to control things. This is what can happen if you put blood red blood cells into different sorts of solutions. This slide, you should pay attention to this slide. There might be a question on the final regarding this slide, hint, hint. So here's a normal red blood cell. The concentration of dissolved solids or dissolved ions in your blood is about 0.9% sodium chloride. So if you have this in a solution where the concentration inside the cell is the same as the concentration outside the cell, there's no net flow of water and the red blood cells stay the same. If you put red blood cells into pure water, there's salt concentration inside the red blood cells. Water will flow into them, causing them to swell and eventually to burst. That's not a good thing if that's happening inside your body. If you put them in a high concentration of salt solution, it will draw the water out of the cells and cause them to shrink. And that has a word, there's a name for that, it's called crenation. Crenation is when red blood cells shrivel up because they're in a solution that is too high in concentration of ions. So that's called crenation. So an isotonic solution, iso meaning the same, it has the same concentration as inside the cells. No, nothing bad happens. Hypotonic, hypo means below. This is a lower concentration of dissolved ions, and so water flows into the high concentration, causing the red blood cells to swell. Hypertonic, too high of a concentration, draws water out of the red blood cells, causing crenation. You can imagine that the concentration of solute in, say, an IV solution would be pretty important, right? An IV solution is going directly into your vein, and if you were to put pure water or something that was too highly concentrated, it's going to really, really mess with your red blood cells. So this idea of isotonic, hypotonic, hypertonic with osmosis is really important in medicine. Any questions?